Solving systems of inequalities, numerically and graphically, using a graphing calculator. Solving inequalities numerically requires using the calculator table. First, we're going to enter the left side of our inequality into y1 and then the right side into y2. We'll use the table to compare the outputs. Whatever the symbol is, in this case greater than, we will be saying when is y1 greater than y2. Look at the table, we notice that they are equal when x equals 8. They both have an output of 47. Before 8, all the y1s are less than y2. After an x value of 8, if we compare their outputs, we'll notice that all the y1 values are greater than the y2 values. So we would say the solution to this would be when x is greater than 8. So the solution to the inequality is x is greater than 8. Any value of x greater than 8 will make the inequality true. If we look at the graph of these, again, with putting the left side of the equation into y1 and the right side into y2, graph it and find the point of intersection. The intersection is occurring at 8, 47. After we have the intersection, we need to compare. We're going to compare y1 to be greater than y2. On our graph, that's going to be when the line, in this case the red one, y1, is greater than or higher than y2. This is happening for the values when x is greater than 8. So we would say that our solution is when x is greater than 8. Pause the video and try solving this inequality. 4x plus 9 is less than or equal to 6x minus 1. Start by entering each side of the inequality into the y equals of your calculator. By entering the left side in y1 and the right side in y2, since the inequality is less than or equal to, we're looking for when the y1 values are equal to and when they're less than y2. First, enter them into your calculator into y1, the left side, and y2, the right side. Now we're going to use the table feature and compare. First, find where they intersect, which happens to be at 5, 29. This is where they'll be equal. And because of this symbol right here in our inequality, we want to include the 5 when x equals 5 because of the equal to part. Now we're looking for when our y1 values are less than our y2 values. As we can see, when when x is greater than 5, that is when we'll see our y1 values being less than our y2 values. So all of the values from x greater than or equal to 5 will make this inequality true. Since the inequality is less than or equal to, we can see in the table that the two sides, y1 and y2, are equal at x equals 5. And the left side, or y1, is less than the right side, y2, whenever x is greater than 5, giving us the solution to the inequality of x is greater than or equal to 5. When we examine the graph of this, with the left side into y1 and the right side into y2, we can see that the intersection is occurring at 5, 29. After we find the intersection, we need to examine the inequality symbol that was given to us. We're looking for when y1 is less than or equal to y2. or when our red line is below or equal to the blue line. So that's happening at 5 and after. So whenever x is greater than or equal to 5, this inequality will be true. Thank you for watching.